Hello, grade 5 math friends. This is chapter 3.1, Adding Unlike Fractions. This lesson has two main objectives. The first is to add two unlike fractions where one denominator is not a multiple of the other. The second is to estimate sums of fractions. Let's begin. We begin this lesson with finding common denominators to add unlike fractions. We begin with a story problem. A plank is painted half red and 1/3 green. The rest of the plank is painted yellow. What fraction of the plank is painted red and green? Well, 1/2 is painted red, and 1/3 is painted green. Before we can add this fraction, we need to find a common denominator. Our first step in doing that is to list the multiples of the denominators, 2 and 3. Let's list the first 5 multiples of each number. We'll begin with 2. 1 times 2 equals 2. There's our first multiple. 2 times 2 equals 4. There's our second. 2 times 3 equals 6. 2 times 4 equals 8. And 2 times 5 equals 10. So here are our first 5 multiples of 2. Let's go through the same process for 3. 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. And 5 times 3 equals 15. Now that we've listed the first 5 multiples for each number, we'll identify the common multiples. Well, let's see. Each has 6. And that's the only one I see. It's also our lowest, so it becomes our least common multiple. The least common multiple is also the least common denominator of 1/2 and 1/3. So we're going to use 6 to rewrite 1/2 and 1/3 as their equivalent fractions. In order to rewrite 1/2 as an equivalent fraction with 6 as the denominator, we have to multiply both the numerator and the denominator by 3, giving us 3/6. So 1/2 and 3/6 are equivalent fractions. Now let's rewrite 1/3. 2 times 3 gives us 6. And whatever we do to the numerator, we must also do to the denominator. So 2/6 becomes our equivalent fraction for 1/3. Now we have two like fractions, meaning two fractions with the same denominators, and we can complete our calculation. 3/6 plus 2/6. When adding fractions, recall the denominator doesn't change. We'll leave it at 6. Then we simply add 3 plus 2 to get 5. So 5/6 of the plank is painted red and green. If we wanted to reflect that on the plank drawing at the top of the page, we would simply go back in and divide this into sixths, where you can see 1, 2, 3/6 are red and 2/6 are green, leaving 1/6 unpainted. Let's work through another problem together. Add 1/2 to 2/7. We need to first find the least common multiple of 2 and 7 so that we can find the least common denominator. Let me teach you a little trick here. Frequently, the least common denominator is simply the two denominators multiplied by one another. Let's see if that works in this case. 2 times 7 equals 14. Now let's check by listing our multiples. So the first 5 multiples of 2 will be 2, 4, 6, 8, and 10. Looks like we need to go a little further. Let's also add 12 and 14. The first 5 multiples of 7 will be 7, 14, 21, 28, and 35. Indeed, our two common multiples are 14, and they are also the least common multiple. So in this case, that little trick works. Now let's convert these fractions into equivalent fractions and complete our calculation. In order to change 1/2 into an equivalent fraction with 14 as our denominator, we'll need to multiply both the numerator and the denominator by 7, giving us 7 over 14. In order to convert 2/7 into an equivalent fraction with a denominator of 14, we need to multiply both the numerator and the denominator by 2, giving us 4/14. As we add those together, remember, when we're adding fractions, the denominator does not change. We use the denominator that we had in the original problem. We simply add the two numerators. 7 plus 4 equals 11. So here is our correct answer. 1/2 plus 2/7 equals 11/14. Let's complete one last problem together before you try a few on your own. 3/4 plus 2/3. Let's try that simple and easy trick for finding the least common denominator again. Does 4 times 3 work? Well, let's see. 4 times 3 equals 12, correct? Let's list our first 5 multiples to see if it really does work. So we'll have 4, 8, 12, 16, and 20 for 4. 3 will be 3, 6, 9, 12, and 15. Well, let's see. Our only common denominator I can see is 12, and that is our least common denominator. So yes, in this case, once again, that easy trick works. Just multiplying the two denominators by one another gives us our least common denominator. Now let's convert these to equivalent fractions and add. Our first step is to convert 3/4 to an equivalent fraction where 12 is our denominator. So in order to get that, we need to multiply both the numerator and our denominator by 3. Our equivalent fraction is 9/12. We need to now convert 2/3 to an equivalent fraction with a denominator of 12. So we'll need to multiply both the numerator and the denominator by 4, giving us 8/12. Now let's add these together. 9 plus 8 gives us 17, and our denominator remains 12. So in this case, we've actually gotten an improper fraction as our answer. If you recall, an improper fraction is a fraction where the numerator is larger than the denominator. In order to give our answer, we could either leave it as an improper fraction, or we can convert this to a mixed number. Remember, a mixed number has a whole number with a fraction attached. In order to convert 17/12 to a mixed number, we would first divide the numerator by the denominator. So 17 divided by 12. And that will give us an answer of 1, correct? In fact, it'll give us an answer of 1, remainder 5. So our remainder will go right here as our new numerator, and we'll keep our old denominator 12. So 17/12 and 1 and 5/12 are equivalent. One is written as an improper fraction, the other as a mixed number. So our answer for this problem could either be 17/12 or 1 and 5/12. If the problem asks you to express the sum in simplest form, it's generally accepted that that means you want to write the mixed number. So whenever a problem asks for simplest form, please be sure to convert your improper fraction to a mixed number. Mr. Giraffe insists that you try some practice problems. The first problem asks you to find the part of the model that shows the fractions 1/2, 2/5, and 9/10. Then write an addition sentence that solves the problem. From that point forward, the problems are simply find the common denominator and add. Each of these problems is on the guide sheet that I sent home with you today. So if you prefer to use that, go right ahead. No matter what, please press pause, go ahead and complete these 11 problems, and we'll be back to work on some estimating in just a moment. Let's complete this lesson by learning how to use benchmarks to estimate sums of fractions. Benchmarks are numbers that are easier to work with and to picture than others. They help compare numbers and estimate answers. So when we're estimating with fractions, we're going to approximate each fraction to the closest benchmark. It's kind of like rounding. Common benchmarks for estimating with fractions are 0, 1/2, and 1. So let's work through a problem together. Let's estimate the sum of 11/12 plus 2/3 plus 1/6. We'll begin by finding the closest benchmark for each number, or for each fraction, 11/12 is very close to 1. If we mark it on our number line, we can see that here it's 1/12, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12 or 1/2. 7, 8, 9, 10, 11/12 would be right here. So it's very close to 1. Our next number is 2/3, which if we consider that in twelfths is what? You're right, it's 8/12. So that would be right here, very close to 1/2. And 1/6 will be way down here, very first tick mark, close to 0. So our estimated sum of 11/12 plus 2/3 plus 1/6 using benchmarks is 1 and 1/2. Let's try a couple more of these together. Let's estimate the sum of 1/10 and 2/5. 1/10 is very close to 0. 2/5 is, I'm going to go with 1/2 as our benchmark for 2/5. So our answer for this one is 1/2. See how this is working? We're simply going to round or use a benchmark to simplify our fractions to 0, 1/2, or 1 and add from there. Let's do another. 8/9 plus 9/10. Well, 8/9 is very close to 1 because it's very nearly 9/9. And 9/10 is also very close to 1 as it's very nearly 10/10. So our answer for 8/9 plus 9/10 is approximately 2. Now let's add 1/6 plus 7/12 plus 5/6, estimating using benchmarks. 1/6 is very close to 0, so we'll benchmark that at 0. 7/12 is very close to 1/2, because 1/2 would be equivalent to 6/12. That's only 1 away. So let's call that 1/2. And 5/6 is very nearly 6/6, which is equivalent to 1. So our estimated answer for this problem is 1 and 1/2. And let's finish up today's lesson with these 3 practice problems. Use benchmarks to estimate each sum. These problems are also on your guide sheet that's been sent home today, so you can either complete it there or in your homework notebook. Thanks for working so hard today, and I'll see you in class tomorrow to practice more addition with unlike fractions.